Hydrogen is the most abundant element in the universe, and it accounts for about 75% of the total mass of the universe. But it's only recently that it's being considered as a source of alternative energy. However, no energy source is ideal, and hydrogen is no exception to this rule. Generally, the manufacture of hydrogen fuel cells requires the use of extremely expensive and rare materials, such as platinum. So we need to find a way to implement hydrogen energy technologies in a practical way. So how do we do that? As a young researcher in biology, I'm convinced that the future of man and technology lies in bioinspiration. So that is to say, drawing inspiration from living things and using the systems that they've developed to help solve our problems. And my thesis project aligns very well with this theme of bioinspiration because I'm trying to understand and interpret the cellular functioning of a bacteria whose metabolic particularity is to produce and use hydrogen gas. The model organism for my research is Desulfovibrio fructosovorans. It has a really long name, but its particularity is that it can use hydrogen and produce and use hydrogen as part of its metabolism. It's also an anaerobic bacterium, which means that it is a living organism that grows in the complete absence of oxygen. And in its genome, we find no less than 6 different hydrogenases. And I'm interested in particular in the hydrogenase H&D, which has a recently discovered mechanism of energy conservation that is exclusive to anaerobic bacteria. This discovery, which is certainly not mine, but I'm involved in with my work, is at the heart of a lot of scientific goals and aspirations. Because if we can fully understand the hydrogen metabolism of this bacterium and the particularities that this bacteria has, one day we can dream of developing a biocatalyst that can replace the conventional hydrogen fuel cells that involve platinum.